manageable chart for you. The homework for each chapter, I've included the homework on the same page. So I've given you the pages in the textbook and the problem numbers. There are a lot of homework. Like I said earlier, if you solve all the homework problems at least 10 times, you should do exceptional in the course. Okay. Have I answered all potential questions, or are there more?
So we submit the homework, or the homework is just for us?
Just for you.
Just for
you.
All right.
Yes. Again, I urge you to email me your questions, to meet me during office hours. Salim, are you trying to ask me a question?
Oh, sorry. I forgot to turn off the handout.
Okay. Barakat? Barakat, any questions?
So I have a question, but it's about the lab. For the lab report you said is due September 9th, but on Blackboard it says the due date is September 1st. I don't know, 1st or 2nd, tomorrow. So which one is the due date?
Could you ask your question again? I'm so sorry.
So I said for lab report 1, you said in your announcement, you said it's due September 9th, which is next week. And then on Blackboard, it says the due date is September 2nd. Or maybe 1st.
September 9th.
Okay.
September. Okay. As a rule, I'd rather not discuss lab during the lecture time. I'd prefer to keep them separate, but I'm happy to answer that question for you. What I will try to do for the lab, let me make a quick comment about the lab. Just to make your life easier, instead of imposing one lab report to you every week, what I've done is that I've given you 2 labs to work with. So every 2 weeks, you will have 2 lab reports to submit. This way you could adjust your schedule, and I think that might work best for you. Okay? Any more questions? Okay, so why don't we begin our study of organic chemistry? Okay, so is it okay to have we all agree that we can record the lectures? Any objection to recording?
I'm okay with that.
It's
okay.
fine. Me too.
So, no? Okay, fantastic. So no objections. So let's begin our study of organic chemistry. Okay, so what is organic chemistry? Well, organic chemistry is the study of the compound of carbon. Here is the simplest organic molecule. It is methane. What I have drawn for you is the familiar Lewis structure for methane. But keep in mind that when we draw this, it is only a representation of the molecule. Let me show you what the molecule actually looks like by using a model. Here is a model of methane, and you could see the carbon here bonded to one hydrogen, a second hydrogen, a third, and a fourth hydrogen. That tells us that the Lewis structures, the flat Lewis structures that we use, are just representation of three-dimensional entities. And you can see that we can rotate this molecule in space, and that gives you a sense of its three-dimensionality here. So here is what we're seeing. It's the model. Of methane. So we go back to our Lewis structures. This is representation of the molecule. In this course, you will learn many other conventions for describing organic molecules. Before the evening is over, you will encounter stereochemical depiction of organic molecules. You will encounter, is there a question?
Yes, we're only seeing you. We're not seeing the screen.
Thank you.
Sure.
This happens all the time. May have to. There's a quirk in this program. I have to turn it off and bring it back. Can you see the screen now?
Yes, I can see the one.
Yes.
Yes.
Okay, good. This is bound to happen quite often, so please feel free to bring that to my attention. So, as the evening progresses, you will encounter condensed structural formulas. I'm not asking you to memorize this thing at this time. It's just a heads up. And you will encounter another way, besides Lewis structures, of describing organic molecules. Now let's go back to our model. And in this model, you could see that the molecule is not flat, but you could see the three-dimensionality of methane. But let's color the hydrogens. Okay. Let's make this one yellow, orange, magenta, and blue. Now you will observe in this model that the blue it's pointing away from you. Okay. Is there a question? Notice, how would you describe the magenta hydrogen? If the blue is pointing away from you, what does it look like to you? This is coming towards, exactly. This is coming towards you. Look at these two bonds here, this one and this bond. They are exactly in the plane of the screen. So this suggests a way of describing organic molecules in such a way that we can convey some sense of their three-dimensionality. Here's a question. Does this make sense to you? The dashed line represents here. Here's the dashed line. The atom that is pointing away from you. And now, this wedge, as it is called, represents the bond that is coming towards you, pointing towards you. And look at these two bonds themselves. The two bonds that are in the plane, they are represented by just straight lines, the usual bonds that we draw. So, in summary, bonds that are coming towards us, we represent them with a wedge. And the bonds that point away from us, we represent them with dashed lines. And of course, the bonds that are in the plane, they're represented by straight lines. Is there a question?
Yeah, like what do you mean by like in the plane? Like you said they're in the plane, like bonds in the plane. Aren't all of them in the plane?
I understand your question very, very well. Can you give me 2 minutes? I'm just going to step outside of my office, see if I can find some models, and see if I can show to you what I mean.
Okay.
Do I have to? Okay, give me a second. Mhm. Okay. Can you guys see my camera? Am I on camera?
Yes.
Yes, I can see your camera and the screen.
Okay, can you see what I'm showing you?
Yes.
Well-
And
The screen is still showing.
Oh, the screen is still showing.
You guys can just click on his name and then make it bigger
Okay.
on the picture.
If I go to my camera and click on my picture, I can make it bigger?
No, the student can do that. They just have to click on where you like where the small picture is showing, and it's going to give them the arrow to make it bigger.
Okay, so let me click now. Okay, good. Can you guys make it bigger?
yes.
Yes.
So it's working. Okay, so the question is, what do I mean by bonds that are in the plane? This is a carbon. This is a hydrogen. This is a hydrogen. This is another hydrogen. And I'm holding one myself. Okay. Now, do you see my napkin? This is the plane.
Yes.
This is the plane. Now, do you see that these bonds, these two here, are perfectly lined up with my napkin?
Yes.
Perfect. Now, on the screen it was magenta, but I have red. Do you see now that the red is coming towards you?
Yes.
You don't see the blue, but do you see that the blue is there, right? But it's pointing away from you.
Yes.
Does that answer your question?
Yeah.
Okay, that's what I mean by those two bonds are in the plane.
Okay. Thank you.
Good?
Mm-hmm.
Sure.
Professor,
Yes.
would you mind explaining again
Explain what?
what you just did?
No problem. Okay. Here's our molecule. Okay. The way that I'm showing it to you, do you see the bond that is red that is coming towards you?
Yes.
Yes. How about the blue? How would you describe it? It
It's
is
away.
pointing away. It's away from. Now the question that was asked is, how do I describe these two bonds? And I said these two bonds are in the plane. And somebody asked me, what do you mean that the two bonds are in the plane? That's what I mean. If the napkin is my screen, you see that these black bonds here are smack against the napkin.
Yes.
That's exactly what we mean by these bonds are in the plane. This one is coming towards you, so we use the wedge. And the blue is pointing away from us, so we use the dash lines. Are we all set?
Yes.
Okay, so we can continue.
Quick question. You said that you were gonna record the session. Is it recording?
Yes, it is.
Okay.
Okay. So you guys can go back to it and review the material at your leisure. So, can you still see my OneNote screen? Still sharing. Okay. So now, we know how to represent bonds that are coming towards us with a wedge. Bonds that are pointing away from us, we use this dash line, and now we know how to represent bonds that are in the plane.
Professor, sorry.
Yes.
Can you make the screen bigger?
I can try.
The student has to make it bigger on their end.
Yes, but I can only see half of the.
Okay. There's nothing to be changed for now. But now, here's the molecule that we're dealing with. Here it is. This is the molecule. Now, I'm going to rotate this molecule in space for you. Before, we had the yellow bond in the plane, the orange bond in the plane. Now we had the magenta was coming towards us, and the blue was pointing away from us. Now I want to rotate this molecule in space. It's the same molecule, but I'm giving you a different perspective on it. Here it is. Now, can you tell me which hydrogen is coming towards us?
The blue one?
The blue one. And which one is pointing away from us?
The yellow?
The purple.
This one, the purple. If the blue is coming towards us and the purple is pointing away from us, what can you say about these two bonds? They are in the plane. They're in the plane. Okay? So how would you represent this? Can you give it a try? Where are we? If I make this the carbon, okay, can you draw the bonds that are in the plane and the bonds that are coming towards us and the one that's pointing away from us? Can you give it a try?
Do you want us to say what's happening?
Yes, I want you to draw it. And this one is also in the plane. The blue is coming towards us. And this one is pointing away from us. It's 710. 712. We'll do it together. Is there a question?
Professor, I had a question.
Sure.
We are drawing this structure.
Let me show you what I mean then. Okay, 712. Which bond is coming towards us? The blue? What kind of bonds do we use? Wedge or dash?
Wedge.
Wedge.
We wedge, correct. So now all we have to do is put a wedge bond here. And just here's the hydrogen. For the purple here, which is pointing away from us, what kind of bonds should we use?
Dash.
Dash.
Dash. And the red is in the plane. What kind of bonds should we use for it?
Single line.
And this yellow is in the plane. What kind of bond should we use?
Single line.
Single line. So by using what we call stereochemical
Professor,
scoring, yes,
can we have the wedge? Can we have the wedge between the straight lines instead of on the corner? Is that okay to do?
I'm not sure what you mean.
Could we have the wedged hydrogen between the planes on the bottom of the carbon instead of up in the
No,
corner?
no. The way I have it.
Okay, why so?
It's a convention.
Can I
It's a
explain it?
convention. It's okay. It's just a convention.
Yeah,
Is this a
basically.
convention?
Let's leave it at that. It's a convention. Okay?
Okay.
Okay. That's the way chemists draw it. Okay. In fact, here it is. The bonds that are in the plane, here they are. And the one that is coming towards you, and the one that is pointing away from you. But let me try to answer your question, why you cannot put it here. Let me try to give you a view, but without the colors, if you don't mind. Okay, so this is the molecule. Imagine this is the purple and this is the blue. Okay, you with me? Okay, now let's rotate this, and this would be the yellow and this would be the red, if you can keep track of the colors. Now let me turn it this way. You recognize that this is the yellow here, and this is the red, and this is the blue that is coming towards us. You see how it's pointing up? And this is the here. See if I can select it. This one here that is pointing away from us. That's why when you draw this wedge bond, you cannot put it down here, if that's what you wanted to draw. And you could just kind of turn this slowly around, make it look more like what we have. And you could see if it will cooperate. But you have these two, yellow and red, in the plane, and this is the blue coming towards us, and this is the purple pointing away from us. So it's just, okay, it's common practice to draw it that particular way. Okay.
Thank you, Professor.
Sure. Now, this way of drawing organic structures is called stereo, right? Three-dimensional, stereochemical.
Professor, we're still doing the 3D molecule. Are we supposed to?
Say that again?
We're still seeing that.
Okay, thanks for pointing that out. I have to stop and go back to sharing the other one with you. Okay, now, this way of drawing organic molecules is called a stereochemical drawing or formula, because it conveys 3 dimensions. So that's a step up from our Lewis structures. Now, let's continue then. Okay, we said that organic chemistry is the study of the compounds of carbon. But the compounds of carbon number in the trillions of the trillions. So they are innumerable. So this is a challenge. So how do we approach that? The study of organic chemistry. Since we have so many organic molecules. Well, here's the trick. It may look like a daunting task, but what we can do, we can organize all these organic molecules into classes of molecules. So now, see, each class of organic molecule, we have the same basic structure. And once you know the basic structure of a particular class of organic compounds, they basically have the same properties, basically the same chemistry. So we don't have to study each of the zillions of molecules that we have. We can simply study all the classes, knowing that each class, in a given class rather, the molecules will have the same basic structure and they will have the same basic chemistry. And that's how we approach our study of organic chemistry. So now we're going to go through all the classes of organic chemistry, the classes of organic compounds, at least what we study in sophomore organic chemistry. Now, here is the first class of organic compounds. Then we have some familiarity with it because they're called alkanes. We've encountered the simplest organic molecule. We've encountered methane before. We've seen the Lewis structure for methane. And now we have mastered stereochemical formulas that convey a sense of three-dimensionality in organic molecules. But the point is, methane is the simplest of alkanes, the first class that we encounter in our study of organic chemistry. But here's a new alkane. It's called butane. This is what butane looks like. It's a little bit like methane-like, isn't it? Except that you have 4 carbon atoms. 1, 2, 3, 4. Note that butane is made up of only hydrogens and carbon. Let's go back. Here is butane, and you will see it's only made up of carbon and hydrogen. So compounds such as butane and methane that are made up of only hydrogen and carbon, they're called hydrocarbons. So the alkanes are hydrocarbons. There are many hydrocarbons. So what differentiates alkanes from the other hydrocarbon? Here's the key feature of alkanes. The key feature of alkanes is that there are, let's highlight this, only single bonds holding the carbon atom together. Only single bonds. Let's take a closer look then at butane. Here is butane again, and I've numbered the carbon atoms. Again, it's a hydrocarbon. You only see hydrogens and carbon.